Okay. Now we have seen for these four types of signals, the Fourier transform is existing or not existing. That depends upon that signal is convergent or divergent. That's okay. Now we come to the Laplace transform. Whether Laplace transform is existing or not for these four classes of signals. Let us see. Now we find the Laplace transform of e to the power of minus a t of t. We have discussed the Laplace transform of x of t. How do you find the Laplace transform of x of t? If I give you x of t and ask you to find the Laplace transform of x of t, how do you find? You just multiply that x of t with e to the power of minus sigma t. After getting the multiplication with e to the power of minus sigma t, then you apply the Fourier transform. So the Laplace transform of e to the power of minus a t e of t is equal to Fourier transform of e to the power of minus a t into e to the power of minus sigma t into e of t. Okay. So this is equal to Fourier transform of e to the power of minus sigma plus a t into e of t. Okay. Now the Laplace transform of e to the power of minus a t of t is equal to the Fourier transform of e to the power of minus of sigma plus a into t e of t. Now ask you one question. The Fourier transform is existing for the signal? The Fourier transform is existing or not? That it depends upon what we have discussed just now. Is it right-sided signal or left-sided signal? Because u of t is there, so it is a right-sided signal. It is a right-sided signal. If it is a right-sided signal, then the Fourier transform will be existing if the coefficient of t should be negative, no? Should be negative. So already minus sign is there. Then what should be the condition? Sigma plus a should be greater than 0. Sigma plus a should be greater than 0. Then sigma is greater than minus a. Sigma is greater than minus a. This is nothing but ROC, region of convergence. Why? Because if sigma is greater than minus a, then only sigma plus a is greater than 0. If sigma plus a is greater than 0, then only this coefficient is negative. Then if that coefficient is negative for right side signal, then the Fourier transform for this signal is existing. That what is that signal? E to the power of minus sigma plus a into t of t. If the Fourier transform is existing for this one, then Laplace transform for this signal is existing. Okay. So here I draw this sigma is greater than minus a in the S plane. Suppose this is sigma and this is j omega axis. This is S plane. Generally, the students get the doubt why the ROC depends upon the real part of S, that is sigma only. This is the reason. See, the Laplace transform of the signal is existing if the Fourier transform of e to the power of minus sigma plus a into t of t is existing, no? So it depends upon the sigma only, not j omega. Why sigma comes into this picture? Generally, the Fourier transform for the signal is existing. Generally, if that signal is absolutely integrable, you take the absolute value, no? When you take the absolute value, e to the power of, what is the absolute value of e power j theta? 1. So that's why the ROC depends upon the sigma only. It does not depend upon the j omega axis. Otherwise, in the equation we have derived with respect to sigma only. So that's why it depends upon the sigma only. Now, can you draw the sigma is greater than minus a? Sigma is equal to minus a. First, you draw the sigma is equal to minus a. Sigma is equal to minus a is a straight line which is parallel to j omega axis. Suppose minus a is there. It is parallel to j omega axis. It is parallel to j omega axis. Okay? Sigma is equal to minus a. Now, can you draw the sigma is greater than minus a? This part. This is the region. This region. See, in this region, the Laplace transform is existing, and in this region, the Laplace transform does not exist. The Laplace transform does not exist. For example, a is equal to 3, then it is minus 3. If you take any point, suppose I take minus 2 plus j5, then Laplace transform is existing at this value of s. When s is equal to minus 2 plus j5, the Laplace transform is existing. If you take minus 2 plus j10, then also the Laplace transform is existing, because it depends upon the sigma only, not j omega axis, j omega value. Suppose if I take minus 5 plus j5, here the Laplace transform does not exist. Laplace transform does not exist. So the ROC is very important, which gives us information where Laplace transform is existing, where Laplace transform does not exist. What is the meaning of Laplace transform is existing? What is the meaning of Laplace transform does not exist? Laplace transform is existing means the x of s at that value of s, suppose s is equal to minus 2 plus j5. If you substitute that value, then its value is infinity. That is the meaning of existing. Suppose if you substitute s is equal to minus 5 plus j5, then its value goes to infinity. That is the meaning of existing or does not exist. Okay? Now, let us see what is the Laplace transform, what is the ROC condition for this e to the power of at e of t. The Laplace transform of e to the power of at e of t is equal to Fourier transform of e to the power of at into e to the power of minus sigma t into e of t. Okay? Now, this is equal to Fourier transform of e to the power of a minus sigma into t into e of t. Okay, again ask you one question. The Fourier transform is existing for this signal? If the Fourier transform for this signal is existing, the Laplace transform for this signal is existing. The Fourier transform for this signal is existing provided what is this e of t is there, no? This is right-sided signal. If it is right-sided signal, what should be the coefficient of this t? Should be negative. That is, a minus sigma should be less than 0. A minus sigma should be less than 0. Then a is less than sigma and sigma is less than a. So this is the condition. That condition is given by the ROC. Now we derive the ROC for these two signals also. The Laplace transform of e to the power of minus at into u of minus t is equal to Fourier transform of e to the power of minus at into e to the power of minus sigma t into u of minus t. Okay? So this is equal to Fourier transform of e to the power of minus a plus sigma into t u of minus t. Again the question arises. The Fourier transform for the signal is existing? You just ask yourself. The Fourier transform for the signal is existing? If the Fourier transform for the signal is existing, then Laplace transform for the signal is existing. The Fourier transform for the signal is existing provided what is the e of minus t is there, no? So this is left-sided signal. If left-sided signal, what should be the condition on the coefficient of t? That coefficient of t should be positive. So minus is already there. So a plus sigma should be less than 0. Then sigma is less than minus a. So this is the ROC. Okay. Finally, we derive the ROC for this signal also. The Laplace transform of this signal is equal to the Fourier transform of e to the power of at into e to the power of minus sigma t into e of minus t. Okay? Then this is equal to Fourier transform of e to the power of a minus sigma into t u of minus t. Okay? Here u of minus t is there, it is a left-sided signal. What is the coefficient of t? A minus sigma. So a minus sigma should be greater than 0. So a is greater than sigma. Then sigma is greater than a. This is the ROC. This is the ROC. Okay.